Hey guys, what's up everyone? How are you guys doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. Today's session is going to be for ICSE 10th Machines chapter, where we'll be talking about mechanical advantage, velocity ratio, and also efficiency of a machine. So without wasting any time, let us get started. But before that, let me introduce myself. My name is Anoop, and I'm a Master Teacher of Science here at Vedantu. Once again, a very warm welcome to all of you guys out there. So this particular chapter in machines, what are we going to talk about as the days go by is in today's session we'll be talking about mechanical advantage, velocity ratios, and efficiency of the machine. Then we'll understand about single or fixed pulleys and single movable pulleys, and then we'll understand about the combinations of pulleys, one fixed and other movable, and then we'll also understand about other combinations of pulley where two blocks and a tackle system. So we'll be talking about all of that in this particular series of machines. So yes guys, let us get started with today's session. So here's the thing guys, machines and man. Now this is not a war that has been going on. It's more like a, it's like a community that we have been going on ahead with our lives, because yes, our lives are so much more easier these days because of simple machines. Every time I think about it, the dialogue from Three Idiots comes into my mind when he comes to engineering class for the very first time. Yeah, so that is what simple machines are all about. All your pulleys, your levers, your screw, your wedge, all of that, your inclined plane, all of these are what are called as your simple machines. Now the thing about simple machines is that it makes our life so much more easier. Think about all the things that you have to do wherein, just by using a machine it makes it so much more easier. So all of that is because of the machine. So it's not really a war like simple machines versus people. It's like I told you, it's like a community, it's like a symbiotic relationship between the both. So let's talk about some of the functions and uses of the simple machines, guys. Now the functions of this and the use of it, you guys know there are tons and tons of them. If you look around yourself, you'll be able to find out so many such examples where simple machines are used. But then let's talk about what are the things that simple machine does to us. First of all, it acts like a force multiplier. Now what do I mean by this? I'll tell you that in a minute. For example, guys, imagine that you want to lift up a car. Now if you want to lift up a car, you would probably need like 5, maybe 10 people who are really strong to do it. Or you could replace all that 10 people with a very simple jack, a simple, lifting jack. By using this one simple machine, you can lift up the car to whatever height you want. Once you find out the center of gravity, you can just lift up the car straight up as well. So you're decreasing your effort by a very, very large extent by using a jack like this. So this is what a jack looks like. So if you look at this, this is where you put in the effort, like where you apply your force, and this is the load. So basically the car is placed on it, and you put your effort over there, and the the load gets lifted up or gets moved by a certain distance. So in this case, you see this, the effort, whatever effort you're putting on the load, it's far lesser. The car weighs a lot, it weighs a lot of, it has a lot of weight. So it varies from one car to another. But yes, the effort that you put cannot be as equal to the weight of the car, because the car weighs a really, a lot. So here, just by using this simple machine, you're able to lift up the same load by putting in very less effort. That is what I meant by a force multiplier. It's increasing your, decreasing your effort, and is able to lift up the same amount of load. So first of all, let me tell you what are these terminologies that I've been using for a long time. That is load and effort. Load is nothing but, guys, any kind of heavy objects or bulky objects that you really want to move. So anything that you want to move, that is called as a load. And the applied force is what is called as the effort. So in other words, load, you can say, is the resistive force. It is trying to resist whatever force you're applying. So whatever force you apply to overcome that resistive force, that is called as your effort. So load is what? A resistive force which tries to, go against whatever force you are applying, and effort is nothing but the force that you put to overcome that resistive force. So it is applied force to make that desired change. That is what is called the effort. Load is nothing but the bulky or the heavy objects that you want to move by applying some sort of effort. As simple as that. Alright, so that is the one thing. Force multiplier, using, you can lift up very heavy loads by using a small amount of force. That is one thing. Secondly, it also is it acts like a convenient. It's you can apply the force wherever you feel is convenient. For example, when you're talking about pedaling a bicycle, it's easier for you to pedal the bicycle straight below your leg than to apply force behind, basically on the back wheel, but you're basically rotating the back wheel to make sure that you're propelled to the front. So here, by applying the force to the pedal, you're actually moving front. So it acts like a convenient point. So it's more convenient for us to put the effort in the pedal, and that effort is basically put on the back tire, and then you have the chains and stuff. So it starts rotating, and then you have the movement which happens, translatory, or in a straight line motion. So basically what you're trying to do is basically make your life a lot more easier by changing the point of application of effort as well. So that is one more thing that simple machines does to us. Apart from that, it also acts like a convenient, it is much more convenient to change the direction as well. For example, if you want to lift up water, it's more easier for you to lift up the water when you're pulling it down, when you're pulling the rope down, than to bend down and lift up the bucket containing water. And it's really deep also. The well contains water which might be really deep. So it's much more easier for you to pull down the rope than to basically bend down and get the bucket of water. So basically, by changing the direction also, the effort that you put in a convenient direction, your life gets a little bit more easier. So that is also one more thing that machines does. Apart from this, gaining in speed, like if you talk about your gear system in your vehicles, or even a simple scissor, all of that actually helps us to gain the speed as well. For example, if you talk about a scissor, whatever movement that you do will be compared, like you just have to do a less amount of movement to get a greater movement of the load. So here again, the speed is multiplied. Your movement is very less. Your fingers move only a little, but then the load on the other hand moves a greater distance. So that is also one more way that machines help our lives to make it much more easier. The gaining in speed as well. Gear system also, if you talk about cars or if you talk about heavy machineries, it makes it much more easier. You can gain the speed because of all the all the gear system that is present inside of that particular machine. So all of these help us in gaining the speed. Apart from these, guys, talking about what are the different factors that decides whether a machine is something that you can consider to be a good one, or something that you would require greater force. So here is one such thing, guys, which is called as a mechanical advantage. So what is mechanical advantage? Is nothing but whatever, it is basically a ratio of the output force divided by the input force. In other words, the ratio of load to the effort. What is the effort? What is the effort that you're putting on top of a particular load? That is what is called as mechanical advantage. So the load divided by the effort, or the ratio of load to effort, gives you the mechanical advantage. Now it's important to understand all these terms, guys, because mechanical advantage of a system will vary. For example, if you say that the mechanical advantage is greater than 1, then you can say that the load is greater than the effort. So whatever, like for example, if you talk about a nut cutter and all that, over there you see this, the effort is much more lesser compared to the load. The load is greater compared to the effort. If in case the mechanical advantage is equal to 1, then the load is equal to effort. For example, in case of a pulley, so more you pull, the more higher the load gets. So that is one more way to say that whatever force you're applying, it's used to do some work. So that's as simple as that. Load is equal to effort. If in case the mechanical advantage is less than 1, then the load is less than the effort, or the effort is greater than that of the load. For example, in case of a lever, so whatever force you apply, whatever effort you put, that will basically be easily, the effort gets multiplied, in other words, or the force gets multiplied. So the load would seem a little lesser, or the resistive force would be much more lesser compared to the effort that you put on it. As simple as that. So mechanical advantage is greater than 1, load is greater than the effort. If mechanical advantage is equal to 1, load is equal to effort. If if in case it is less than 1, then the load is less than the effort, or the load is effort is greater than the load. Simple as that. Now to talk about the second one, guys, that is the velocity ratio. What is this velocity ratio? Is nothing but, in simple words, it is the ratio of velocity to the effort to the ratio velocity of effort to the ratio velocity of the load. Or you can also write it in terms of distance as the distance moved by the effort divided by the distance moved by the load. Both of these are correct. If in case they have given you velocity in the question, then you can take this equation, that velocity of effort divided by the velocity of load. If in case they've given you the distance, which most probably is, then you can remember this formula, that is velocity ratio is equal to distance moved by the effort divided by the distance moved by the load. As simple as that. Next one is nothing but the efficiency of the machine. Now, efficiency of the machine is something that you've probably heard about several times, over the years. Like so you would have heard that certain machines are much more efficient, like all the new age, if you talk about bikes itself, or if you talk about cars, the new engines are much more efficient than the older ones. These are few terms that you've heard over the years. So what exactly is the efficiency? Efficiency is nothing but the ratio work done by the load on a machine to the ratio work done by the effort on the machine. So whatever the work done by the load divided by the work done by the effort is what is called as efficiency. So you can write it as efficiency is equal to output work divided by input work. Or there's another way to write this. So efficiency is represented as eta. So this is how you represent efficiency. Efficiency can also be written as the ratio of mechanical advantage to the velocity ratio. So the mechanical advantage divided by velocity ratio into 100 would give you the efficiency in terms of percentage. So that is also one more formula that you have to remember. So in conclusion, guys, what do we see so far? Mechanical advantage is load by effort, which is L by E. Velocity ratio is either you can write as velocity of the effort divided by the velocity of the load, or effort distance, the distance moved by the effort divided by the distance moved by the load. And efficiency is nothing but output work by input work, or you can also write it as efficiency is equal to mechanical advantage divided by the velocity ratio into 100, which would give you the percentage of velocity or efficiency. So that's it, guys. Now to tell you a couple of things that you'd have been wondering. For a machine, when you say if it's a force multiplier, if you say that it's a force multiplier, like in the case of jack and all that, over there the mechanical advantage will be greater than 1, and also the velocity ratio would also be greater than 1. If you talk about gaining in speed, like in the case of the gears, or if in the case of scissors and all, the mechanical advantage would be lesser than 1, and the velocity ratio would also be lesser than 1. If we talk about convenient point and convenient direction, in both the cases mechanical advantage and the velocity ratio would be equal to 1. Like in the case of a pulley, one of the simplest example, in the case of a pulley, you can give that as the example of convenient point as well as convenient direction, where you see that the mechanical advantage as well as the velocity ratio is both equal to 1. As simple as that. Now that you've understood all of this, guys, one more important thing that I want to tell you guys is this. As you guys, many of you guys already know about it, on 28th of this August, we have one of the biggest celebrities in sports history coming to Vedantu, and that is Miss PV Sindhu ma'am. She'll be joining us, where she'll be talking about her efforts, what all she has done in her past to get to where she is, and it'll be a good talk. If you really want to watch this live, you can register on this link that is there over here, https://vdnt.in/Sindhu. So register to it so that you'll also be a part of it. Now already there are lakhs and lakhs of students who have already registered, so before the seat runs out, make sure that you register for that as well. With that said, guys, let us now solve some questions. So yes, the questions, now as always, I would want you guys to solve the questions by yourself. Try to give down the answers in the comment section below. The questions might be a little, not hard, but it requires a little thinking. So yes, try to do your best and put it down in the comment section below. Alright guys, so here's the first question. A force of 20 Newton rises a load of 100 kg. Calculate the mechanical advantage of the machine. Is it 75, 100, 50 or 25? You're supposed to calculate the mechanical advantage. They've given you the effort, they've given you the load also, but in terms of kg. So they've given you the mass. You're supposed to calculate the mechanical advantage. First of all, write down the formula. What is the formula of mechanical advantage? Mechanical advantage is equal to load by effort. Load by effort. All right. Now in this case, the load is given. The effort is given. Effort is directly given as 20 Newton. Effort is given as 20 Newton. But the load, on the other hand, is given in terms, they've given it in terms of kgs. So what you have to do is calculate the weight, calculate the force. So if you remember the formula of weight, which is nothing but the force applied by the gravity, by the force of gravity. So weight is what? Mass into acceleration due to gravity. So I'll take acceleration due to gravity as 10 to make my life a little bit more easier. So I'll take it as 10 meter per second square. So to find out the load, basically you have to use the formula of weight. So it will be 100 into 10, which would give me 1000 Newton. So I have to find out in terms of Newton. So that is basically the weight, which is the force applied, that is 1000 Newton. Now put it on the equation. So mechanical advantage is equal to load is 1000 divided by the effort, that is 20. 0 gets cancelled. 2, 5, 10 and 0, that's 50 would be the mechanical advantage. As simple as that. So the answer to this question would be option number C, which is 50. As simple as that, guys. Like I told you, a little bit, it might be a little confusing, but then once you keep practicing these questions, it'll get a lot more easier. So make sure that you practice a lot of questions from your textbook, whichever textbook you guys are referring to, Selena or any other book for that matter. Try to refer those textbooks. Try to solve as many questions as you can. That would be a good practice. All right. Second question, guys. Here we go. In a certain machine, of force of 10 Newton moves down a distance of 0.05 meter. In order to raise a load of 100 Newton through a height of 0.5 centimeter. Calculate the velocity ratio of the machine. Is it 0.1, 2.5, 10 or 5? So they've given you the force, that is, they've given you the effort, they've given you the distance moved by the effort, they've given you the load, they've also given you the distance moved by the load as well. You're supposed to find out what is the velocity ratio. So is it 0.1, 2.5, 10 or 5? First of all, write down the formula. Velocity ratio is what? The distance moved by distance. My handwriting is a little clumsy, guys. Please try to understand it. So distance moved by the effort divided by the distance moved by the load. Distance moved by load. So here in this case, they've given you the distance, both the distance are given, that is 0.05 meters and 0.5 centimeters. So first of all, change the unit, make sure that all the units are the same. So to find out that the distance moved by effort, I'll just write it as distance moved by effort. So distance moved by effort is equal to 0.05 meters. So convert that to centimeters. So into 100, that will give me 5 centimeters. It'll give me 5 centimeters. And to talk about the distance moved by the load, that is already given us 0.5 centimeter. So put on the equation, velocity ratio is equal to distance moved by the effort is 5 and the distance moved by the load is 0.5. If you divide it, so you can do it, you can multiply it by 10 and divide it by 10. So you would get it as 50 divided by 5, just to make your life easier, and you can give it as, so the right answer would be 10. As simple as that. So the velocity ratio would be 10. As simple as that, guys. Like I told you, questions are easy, but then it requires a little bit of thinking. The right answer to this question is 10. That's all, guys. Moving on to the next question. How is mechanical advantage related to velocity ratio for an ideal machine and a practical machine? All right, so here's the thing, guys. They're asking you what would be the relationship like, or what would be the relation between mechanical advantage and velocity ratio if in case the system is ideal. That means there is no loss whatsoever. Whatever effort you're putting, you're getting the same amount of the same amount of work done. Work is also done. So in that case, what would be the ratio between the mechanical advantage and velocity ratio? And in a practical machine where there's a lot of loss and there's a lot of inconsistencies in terms of the work, the input work as well as the output work. Let's talk about that. So here are the options, guys. Option number 1 is mechanical advantage is less than the velocity ratio, and option number 2 is mechanical advantage is greater than velocity ratio. B is mechanical advantage is equal to velocity ratio and mechanical advantage is less than velocity ratio. Option number C is mechanical advantage greater than velocity ratio, mechanical advantage less than velocity ratio. Option number D is mechanical advantage is equal to velocity ratio and mechanical advantage greater than velocity ratio. The answer to this question, guys, I'll tell you this, it is actually option number B. Why? Because in an ideal system, in an ideal machine, whatever effort you put in, the same amount of work would be done, or whatever input work is given to it, the output work would also be the same. There'll be no loss whatsoever. Like for example, if you talk about let's say that let's say that you have a bike, or let's say you have a bike. So 1 liter of petrol gives you so much mileage. You know about the mileage, right? It goes so much distance. So if it's ideal machine, there's no loss whatsoever, then the efficiency would be much more greater. Like I'll just give you an example. Like if you want to give an example, like for example, if you talk about Splendor, and if you talk about, let's say, a bike like Royal Enfield, 1 liter of petrol would give you like around 69-70 kilometers, or maybe even 100 kilometers in a Splendor. Whereas if you talk about a bike like Hero Honda, like sorry, your Royal Enfield, over there you'll get like 25, maybe 30 kilometers. I'm not really sure about it, but yes, somewhere around that. So you see, this 1 liter of petrol does so much of so much of work over here and little over here. So in an ideal system, it will be equal. Mechanical advantage will be equal to velocity ratio, and in a practical machine, the mechanical advantage will always be lesser than the velocity ratio. So you will not actually get the equal amount of load and the equal amount of work done to the amount of work that you put in. So it's not that it is not always the case. There'll be a lot of loss in the form of heat. Like if you talk about a machine like bike machine and all that, there's a lot of loss happening in the form of heat and friction and all that. They have to overcome the friction and stuff like that. So all of those have to be considered as well. Anyways, moving on to the next question, guys. Here we go. So the answer to this question is option number B. Moving on to the fourth question. Here's the question: a mechanical system has a velocity ratio of 4 and an efficiency of 90 percentage. All right. If you talk about calculate the mechanical advantage of the system as well as the effort required to raise the load. If the load is 300 Newton by the system. So your options are 1.25, 72.5, 3.6 and 83.33, 4.7 and 83.33, or option number D, 2,4 or 2.4, maybe it's not 2,4, 2.4 and 50. So these are the options. You're supposed to find out what is the mechanical advantage, as well as you're supposed to find out what is the effort required as well. So you're supposed to calculate both of them. They've given you the efficiency. The efficiency of the system is 90%, and also they've given you the velocity ratio to be 4. First of all, guys, write down the formula. So I just told you this, that efficiency, that is eta, is equal to mechanical advantage divided by velocity ratio. I've told you this before, right? So first of all, rearrange the equation, because you know the efficiency. They've given you the efficiency, they've given you the velocity ratio also. Find out mechanical advantage. So for the first one, I'm going to find out the mechanical advantage. So mechanical advantage is equal to basically eta into the velocity ratio. So basically it's given in percentage, so it will be 90 divided by 100 into because it's given in percentage. The formula itself is into 100. If you guys remember, it's into 100. So VR is basically 4, that is velocity ratio is 4. So if you simplify this equation, 0 0 gets cancelled, 2 5s are 2 5s are 10, 2 2s are 4. So it's 18 divided by 5. 5 3s are 18. You'll get it as 6, I guess. So you'll get it as 3.6. That is the mechanical advantage. Now that you find out the mechanical advantage, you have to find out the effort. So the formula for effort, or if you remember the formula of mechanical advantage is equal to load by effort. You know the load is 300 Newton. Find out the effort, rearrange the equation to get you this thing, sorry, load by effort, I wrote it as E, sorry. So effort is equal to load by mechanical advantage. So load is how much? It's 300 Newton divided by mechanical advantage is 3.6. So you would get the answer for this question. So if you divide it, you'll get it as 83.33. As simple as it is. And you found out the mechanical advantage to be 3.6. As simple as that. So the answer to this question would be option number B, which is 3.6 and 83.33. Simple as that, guys. I know the question might seem like it's confusing, but it's actually pretty simple. You just have to do a little bit of calculation, that's all, and then you'll get the answer. And these are one of the most different questions that can be asked from this chapter. Here's the last question, guys. In a certain machine of 10 Newton moves down a distance of 5 centimeter in order to raise a load of 80 Newton through a height of 0.5 centimeter. Calculate the mechanical advantage and velocity ratio, and calculate the efficiency of the machine as well. So these are the options. Mechanical advantage is 10, velocity ratio is 10, efficiency is 100%. 10, 8, and 80%, 8, 10, and 80%, and 8, 8, and 100%. So this is the question, guys. First of all, write down the given data. What and all is given? They've given you the effort. They have given you the load. They've given you the distance. The distance of the effort. They've also given you the distance by the load as well. Distance moved by the load as well. So calculate the mechanical advantage. So you know the formula for that. So for the first one, I'm just going to write down the like the formula and then the substitute the values. So mechanical advantage is equal to load by effort. So load is given as 10 Newton. Sorry. 80 Newton, and they've given you the effort to be 10 Newton. So you'll get as 8. Simple as that. So the answer to that first question is 8. First part of the question. Now to calculate the velocity ratio. Velocity ratio is basically the distance moved by the effort divided by distance moved by the load. So distance moved by the effort is how much? It's 5 centimeters, and distance moved by the load is 0.5 centimeters. Again, multiplied by multiply and divided by 10. Or you get as 10 itself. In other words, so you'll get as 50 divided by 5, which is nothing but 10. So the answer is 10. Now to calculate the efficiency for the of the machine is basically efficiency. Eta is equal to mechanical advantage by the velocity ratio. Mechanical advantage is 8, the velocity ratio is 10, so you'll get it as into 100. So you'll get it as how much is that? So that's 0.8 into 100, so that'll be 80%. Simple as that, guys. So that'll be the answer for this question. The answer to this question would be option number C, which is mechanical advantage 8, velocity ratio is 10, and efficiency is 80%. Simple, guys. Very simple. Like I told you, it requires a lot of effort. It's not like it just came in the middle of the night for me also. You have to put in the effort, only then you'll get there. So yes, guys, that is it for today. And this, my friends, is the homework for today. And yes, I want to see all your answers in the comment section below. Here's the question. When a machine pressed by effort moved down a distance of 100 centimeter, while the load is raised through 25 centimeter, at the same time find the velocity ratio. Very simple. They've given you the distance moved by the load. They've also given you the distance moved by the effort. Find out the velocity ratio. Very simple. I want to see the answers as soon as possible in the comment section below. With that said, guys, thank you for joining. I hope you guys enjoyed today's session. If you did, like and subscribe to the channel so that you are notified, and click on the bell button as well so that you get notified of every new video that comes out. Thank you for joining, guys. Until the next time we meet, this is Anoop signing off for the night. And if in case you want to reach out to me, this is my email ID as well, anoop.manoharan@vedantu.com. So I'll catch you guys in the next one. Take care of yourself. Stay safe. Bye bye.